All right, welcome to Notes on Symmetry. This is going to be for Monday this week, but this is our Notes on Symmetry. This is page 38. This is going to be our last set of notes for this unit. So we need to start preparing for the assessment after this, but this is the last set of notes for this unit. All right, so let's look at this. It says symmetry. A shape has symmetry when it can be what or what onto itself. Well, I want to use the words flipped or turned onto itself. And that should make sense that if I have a figure, let's say a snowflake or square, if I turn it or I flip it, it should be the exact same and should look the exact same as I do that. The next part of this, three types of symmetry are going to be line, point, and rotational. And we just did rotation this set right before this one, so you should be pretty familiar with rotational symmetry, but there are three types of symmetry. That is line, point, and rotational. The next one, line reflectional symmetry. Well, remember what reflection means. It means kind of that mirror image. So line symmetry occurs when two halves of a figure mirror, and we're going to use that word mirror, each other across a line. Now remember that this has to be, since it's symmetry, it has to be, the images has to be isometric, which means they have to be the same size and shape as I do this, right? So if I cut it in half, one half has to be the same as the other half, and they have to be identical. Okay, they have to be identical as I do this. All right, if you need to pause and catch up, go ahead and do that at this time. Otherwise, we're going to go ahead and turn the page. So, some ideas of lines of symmetry. Notice in example 1, there is a line going through the capital letter A, and it's just one line, and it's the only one I can do. I can't go horizontal, I can only go vertical through A, because if I go horizontal, the bottom half is not going to match the top half. But if I literally cut that capital letter A exactly in half, I could fold it onto the other side, and it would be symmetric. So we would say that this has one line of symmetry, and there's only one line. I can't force another one in there. Like I said, I can't cut it in half horizontally. I can't do it diagonally. I can't do anything like that. So in essence, I only have one line of symmetry. I can only cut it in half one way. This second one looks like a little flower. As I see it, I've got some dotted lines going through it, like this, there, and there. In essence, what is that saying is that if I cut this flower on each of those lines one at a time, I would be cutting it in half. I would be cutting it to be a mirror image of each other. So this one is an example of three lines of symmetry. So this has three lines of symmetry. Now, where you're going to use two more examples, something that to kind of just draw anything. The first thing I'm going to think of is, well, let's do a heart. And if I draw a nice heart, now remember my drawing skills aren't the best, but if I draw a heart, I want to ask myself, how many times could I cut this heart? Could I cut it horizontally? Do I cut it diagonally, or can I cut it only vertically? Well, I know if I try to cut it horizontally, that's not going to match. If I try to go a diagonal, those aren't going to end up matching if I fold it onto each other or have a mirror image of each other. So the only way I could cut this heart in half is vertically, and that is literally in half. So as I do that, How many lines of symmetry am I going to have? Well, obviously just one. So this is a one line of symmetry. Okay, the next one I'm going to look at, change colors, give a little bit of different color here. Let's do a perfect square. Remember, a perfect square is going to have the same size, each side is going to be exactly the same distance, right? So each line segment there is going to be the same distance. It forms 4 90-degree angles and all that. Well, as I look at this square, I ask myself, how and where could I cut it in half and fold it or turn it and make mirror images? Well, I know I could cut it in half vertically because each side is equal. I could also do horizontally because I could fold it down. And then I look at it and I go, well, wait, if those weren't there, I could also cut it diagonally this way and diagonally this way. And if I all said and done, I look at that and I count the number of ways I could cut this, this ends up being an example of one that has 4 lines of symmetry. So 4 lines of symmetry. Let me get out of the way so you can write. But this has 4 lines of symmetry. So it has each side is equal. I could cut it 4 different ways, fold it on top of each other, and it would be symmetric. All right, once again, you need some time to catch up. Please pause, do your thing, and then I'm going to go ahead and start moving forward. All right, turn to the page. So page 3, I'm going to get a different color here. These are going to be some examples of images that do not have lines of symmetry. So they do not, that's the key to this one. I do not have lines of symmetry. So I'm looking for examples that I can't have a mirror image if I cut it in half. It's not a mirror image. Well, the Z, if I tried cutting it, and I'm going to do a different color, if I tried cutting it on this dashed line that's through there, well, those aren't going to fold on top of each other. Because if I fold this part down, it's going to end up over here. It's going to end up over here. It's not going to fold perfectly. I would have to turn it. I'd have to do some other modifications to get it to be on top of each other. So this is an example of a non-line of symmetry. All right. The parallelogram. Well, if I cut it in half, and I go this way, and I try to cut it in half, and I once again try to fold one of the sides down, it's going to end up, this is going to end up over here somewhere. This one would end up probably over here as I fold it down. But this is another example of a figure that is not going to have a line of symmetry because it does not fold on top of each other. Okay? This does not fold on top of each other. Okay? Use those lines that I already wrote. So it doesn't fold on top of each other. Alright, example 3. Let's see. Let's kind of get funky and creative here. Alright, let's go a hand. Remember, I'm not the best drawer on the word, so don't make fun of my artistic ability. But you get the idea. It's kind of a misshapen hand. It's got a really big thumb. Okay, a really big thumb, and that thumb is going to help me with my doing of this. If I try to cut this in half, well, obviously if I try to cut it in half, that thumb is never going to fold onto anything else. It doesn't fold onto the pinky. If I try cutting it in half this way, well, that once again, that thumb is there, and it doesn't fold onto anything. So this, a hand, would be a great example of a non-line of symmetry figure. Okay, non-line of symmetry figure. All right, let's look at another one. Kind of be creative. All right, thinking creative. Oh, I got one. Let's do a face. a face, drew a little nose, drew a mouth, get some eyebrows in there. He got funky and did a little green hair. He went crazy. He got some hair. All right. He decided to get. He's got a little bigger ear. Somehow he's got a little small ear over there. Maybe a little Fu Manchu going right there. He's got a little growth on the bottom of his chin, but you get the idea. It's a face, right? It's a face. Well, like everyone's face, it's not perfectly symmetric. You may have a dimple on one side. You may have a scar on the other. Your ear may be a little bit misshapen. All those kind of things. But in essence, I can't cut it in half. I can't cut it in half and get it even because our faces aren't perfectly symmetrical. Okay, so this would be another great example of a non-item, a non-figure of a line of symmetry. All right, because faces are non-symmetric. All right, any questions on these, please feel free to ask. Go ahead and pause if you need to, but these are good examples of non-images that do not have lines of symmetry. All right, they are not symmetric. All right. And last but not least, draw the lines of reflectional symmetry for a rectangle. Well, remember, a rectangle has both the the widths are the same and the lengths are the same, but they're not all four the same distance. Just the widths and the lengths are the same. So as I look at this, I think I could cut this in half and fold it all over. If I went this way, I could cut it in half. And then I could also cut it in half this way and do that. But since the widths and the lengths of this are not the same, this is all I can do to cut it. I can't do like a square where I can do diagonally. Rectangles only allow me to do vertically and horizontally. So this is going to be one that has just two lines of symmetry. Two lines of symmetry. And that is a rectangle because not all four sides are equal, so therefore it's not going to be perfectly symmetrical four ways. I only have it vertically and horizontally. All right. Now, look at the last one. It says, recall the definition of a regular figure and see the relation to the number of sides and the number of lines of symmetry. Well, it says regular polygon. Well, what is a regular polygon? Well, a regular polygon has all sides are congruent, which means what? They're all equilateral, right? All equilateral. And then all angles are congruent as well. And we call that equiangular. So this means equilateral and equiangular. And make sure I spell this correctly. Equilateral. And the last one would be equal angular. All right. But the bottom line on this is a regular polygon is going to have all sides that are congruent and all angles are congruent. Now, the relation to the number of sides and the number of lines is symmetry. Okay? So if a regular figure has the same number of sides and the same number of symmetry, that means whatever shape that is, whatever the number of sides are, is the number of lines of symmetry. So as I look at this, and I'm going to write that out here because I want to make sure I drive that home. I'll put it in green. The number of sides equals the number of lines of symmetry. Okay, so number of sides equals the number of lines of symmetry. And I've got two examples here for you to take a look at. I have a octagon which has 8 sides, and as you can see there are 8 sets of dash lines going through the octagon. So it has 8 sides. Once it has 8 sides, you can count up all these diagonals and it would have also 8 lines of symmetry. The next one over here in blue, it is a pentagon because it has 5 sides. You count up the number of dash lines that I have, and it would be 5. So the number of sides, since these are regular polygons, all sides, all angles are going to be congruent, which means they're going to be equal. Tells me that they're going to have the same number of sides and the same number of lines of symmetry. All right, this is going to conclude our notes. We will see you in class. Ask any questions that you may have, and thank you very much for watching.